and it's helpful for your co-op interviews. So our agenda is we'll tackle 3 easy problems to start off with. Two sum, best time to buy and sell stock, and contains duplicate. It's associated with arrays. So I hope that you learned arrays in your classes, but if not, we can explain the concepts clearer. So Vansh, can you start off with a big O notation?
Cool. Can you hear me?
Yeah.
All right. So let's start off with the big O notation. So big O is basically a function which we use to narrow down any function to time complexity or space complexity. And this is sort of like a mathematical definition of it. And it kind of looks overwhelming, I know. But yeah, basically we have two functions, f of n and g of n. And these are both functions of an unbounded set, and we only work with positive integers when we use time complexity, because the size of an array, it cannot be negative, or size of any data structure, we use positive integers for it. Now, how to define big O? Big O is basically f of n is equals to O of g of n. If and only if there exists a positive constant c and a non-negative integer n naught, such that f is less than c times g of n for all n greater than equal to n naught. Now, again, this looks so much overwhelming, so let's look at the easier definition of it. So big O notation is a way to track how quickly the runtime grows as compared to the size of the input. So the basic fundamental here is, uh, let's say the size of the input is n. So based on that size, how much time the algorithm is taking. That's how you define big O in the easiest way, I guess. And in big O, we always take the worst case scenario, which is also called the upper bound. So in your algorithm, there might be a situation where we reach the solution a bit faster than we planned. That's caused the best case scenario, but while calculating the time complexity, we always take the worst case. So what's the most amount of time the algorithm is going to take when the input is the largest? Basic. And okay, and the final point here is we do not consider stuff like processors, languages, or any external factors while calculating it. We are purely going to look into the size of the input, and based on that, we're going to look for the time complexity. So this is the basic meaning of big O, or time complexity. And if you guys have any questions up to now, put it in the chat. I don't see many people here anyway, so. All right, so there are different kinds of time complexities, again, based on what result you have. So the first one we have is constant time. So this is also called big O of 1 or big O of constant. Why? Because you see in the brackets, there have to be a variable. When there's no variable, that means whatever we are doing with this function is constant and it doesn't depend on the size of the input. So whatever the size of the input is, the time complexity is going to remain constant because it doesn't depend on that variable. In the solution, we can see, in the example, we can see the input is an array of integers and it's called numbers. But what we're doing in the, what's up? Oh, sorry, I thought it's Fizan. Okay, so so the input here is a array of integers, and we are calling it numbers. And what we're doing in the solution is basically returning the first value out of it. So to be honest, it doesn't matter what the size of the input is here. It can be 1, it can be a million. The program's gonna run in a bit because we're just returning the first value of it. So yeah. in constant time complexity, doesn't matter what the size of the input is. It's always constant. Now, something which depends on the size of input is linear time complexity. As we can say, it's also called big O of n. And again, n here is a variable. So now we are depending on the value of n. If the value of n is very big, that means going to take a longer time to execute. And if the value of n is small, then it's going to take a smaller time to execute. So that's why it's called linear time complexity. And as the size of the n changes, the value of the time complexity is going to change linearly. That means if, let's say, for n equals to 1, it's going to take 1 second to run the program. For n equals to 1,000, it's going to take 1,000 seconds. So it's always going to be linear. Just an example, it's not going to take 1 second to run the whole code though. So in the example, we can see, again, same thing. We are taking an integer array as an input. And what we are trying to do here is we are trying to print the sum of all the elements of the array. And since, let's say, the array has 100 elements, then this loop's going to run 100 times and it's going to return the sum. If the array has 1,000 elements, same thing's going to run 1,000 times and then return the output. So based on the size of the input, it's going to run as many times as the value of n. So that's called linear time complexity. It's going to take a longer time to execute this whole solution. Okay, again, this is kind of similar. It's called quadratic. In this one, again, we are depending on the value of n here, but it's even worse than previous one because in this one, as you increase the value of n, the value of time complexity is going to be increasing based on the square of that value. So again, same example if I give you, for n equals to 1, the value of time complexity is going to be 1. But for n equals to 2, the value of time complexity here is going to be 2 raised to the power 2, which is 4. And if you bring it down to the higher value of n, let's say 1,000, then the value of time complexity is going to be 1,000 raised to the power 2, which is 10 raised to the power 6, 10th a million. So yeah, it's kind of worse because for bigger inputs, this program is going to take a longer time to run. So yeah, we should avoid quadratic time complexity while creating an algorithm. And most of the sorting algorithms are O of n squared. And again, in this example, we have an array and we are trying to print. So we have these two loops inside each other. So these are called nested loops. And we are trying to print out all the elements of this array one by one. And these are all the functions we have based on the time complexity. We already talked about constant time. We talked about linear. We talked about quadratic. The other ones we have is logarithmic. And this is basically in ascending order. So as you go down, it's going to become more complex, going to take a longer time to execute. So O of 1 is the best time complexity. And as you go down, it's going to take even longer time. For example, O of 1 is constant, so it's going to take same amount of time for any input size. So again, for logarithmic, it's better than O of n because if you plug in any value of n and compare these two outputs, you'll see the result. For example, let's say n is 1,024, and let's say the log base we're using is 2. So for the second one, log 1,024 is going to be just 10. And as compared to O of n, where if n is 1,024, then the value of O of 1,024 is going to be 1,024 again. So yeah, that's about big O and time complexity. Cool. David, you can take over, man.
All right, so let's try to do some problems. So the first problem is the two sum. Let me if you Google LeetCode two sum code blind 75, you'll see the problem, and it's basically you're trying to find the target with the elements in the array. Let me go to that problem. So it says, given an integer array, nums return true if any value appears at least twice in the array and returns false if every element is distinct. So in this example, so we have a made up example of 3, 2, 4 in the array that targets 6. So it goes in the first the 0 index. Sorry, I apologize. My throat is I'm kind of coughing, so I apologize that in advance. So it's a 0 index for the first element, and for the first loop, it goes to check. It goes to the inner loop, inner loop, and it checks if 3 plus 2 equals 6. It does not. Then it goes to check if 3 plus 4 equals 6. It does not. Then it goes from the outer loop to 2, which is the first index, and it checks if it's 2 plus 4 equals 6, and that is equal to 6. So the output would be 1 and 2. So this would be the brute force method. So it would be n squared because there's 2 loops attached to it. So the time complexity for this is O of n squared. So would you guys like to try the brute force method, like code it out? Or do you have any questions? Like you can try to ask. Okay, so all right, so then here's the solution. I'll explain the solution. So yeah, there's a class named solution is defined as automatic with the method header. Yeah, it returns array int array. The method is called toSum because we're trying to find the target with whatever the two like basically the two numbers in the index. So the first outer loop, it starts with 0 index and it goes through the length, basically length nums dot length minus 1 because it's not greater, less than nums length, which is basically less than or equal to nums length minus 1. And it's I plus plus because it goes to the next element after each iteration. And the inner loop is int j equals I plus 1 because you don't want duplicates, like you want to start to the right of the um outer loop. For example, in the picture I showed you, like it starts off with 3, so it checks 2 in the inner loop. If it starts at 2, it checks 4 in the inner loop. Yeah. And then after you go through a loop, it basically checks if it's the target, and it returns basically the two numbers or the indices that respond that does the target. And if it does not reach the target in any combination, then it throws a legal argument exception, no toSum solution. Okay, do you have any questions regarding this, or you guys are all good? Yeah, this is the brute force. So this is the more like the slowest method or the beginner friendly method for the people just starting off. So we're gonna learn more advanced methods like using hash maps soon. So this is the brute force where brute force basically means we check basically every number until we get a target. That's why it's slow. Okay. So Ashton, do you want to explain the solution in Python?
Yeah, for sure. Can you hear me all right?
Yeah.
Okay. So yeah, similar in Python for the brute force solution, you're going to use a nested loop. So we're creating the class solution or defining the function toSum, which takes nums, the array, and target, which is the target sum. So the first loop we have for I in range length of nums. So we're going to iterate once for every item in the array nums, the list nums. And then we have the second, the next array in range I plus 1 as the starting index up until the length of nums as the ending index, non-inclusive. So basically what that means is, do I have control of the, okay, great. So if we're looking at this example, if we're starting on the first element, so index I is starting at 0, j will be starting at I plus 1, which will be 1. First, we're going to have I on 3 and j on 2. We're going to add those up in the conditional. So if nums of I plus nums of j is equal to the target, so if 3 plus 2 is equal to 6, we're going to return the indices of I and j, because that's what the problem is asking for. So obviously 3 plus 2 is not 6. So then we're going to try, the inner loop is going to iterate again, and j, which was on index 1, which equals 2, is going to be incremented to index 2. I is going to remain on index 0 on the 3. So then we're going to do 3 plus 4. We're going to check if that's equal to 6. Obviously, it's not equal to 6. So then j will be now out of range because it'll be greater than, well, it won't necessarily be greater than the length, but it'll be greater than, it'll be outside the array because this is non-inclusive at the end. So it won't go, even though the length of the array is 3, it won't go to index 3. Just stop at 2. I will then be incremented to 1. Index 1 of this array is 2. And then, of course, the inner array, or sorry, the inner loop will begin at I plus 1 for j, which is equal to 2. The element 2 in the array is 4. And it's going to check, is 2 plus 4 equal to 6? That's true. So it's going to return I and j, which we know are on, in I is equal to 1, and j is equal to 2. So because that if statement executes, it evaluates to true, we're going to return I and comma j, which will be 1, 2, 1 and 2. In Python, if you just return it like this, it'll just automatically turn it into an array. So it'll just be an array that contains 1, comma 2. And that's how it works in Python. David, I don't know if you wanted to screen share, and maybe we could do some like demonstrations of other test cases in LeetCode. David, are you still there?
Sorry, yeah. Do you want to share your screen or how do you want to do it?
I'm not sure how screen share works in this, but
You just click the share button, the up arrow.
can I share like just my browser? Does that work?
Yeah, you can show
Okay.
your window.
Okay. Can you see all right?
I can see, but it's a little small. There
How's
we
that?
go. Yeah.
Okay, give me 1 sec. All right, you can see it, right?
Yeah.
So basically for I in range, like the nums, for j in range I plus 1, comma, length of nums. All right, so there's our nested loop. In that we have to have the conditional. So if nums of I plus nums of j equals target turn I, comma, j. So you can see some test cases here on the side. It's going to give us this array, this target 9. So if you look at this array, to get the target 9, you need 2 and 7 from this array, right? So the output that it's looking for is 0, comma, 1. And obviously it gives you the explanation was because nums of 0 plus nums of 1 is equal to 9, you return 0, 1. Same with this one. If you want 6, this is like the example from the slideshow. And this one, 3 plus 3 is equal to 6. We run it. It's accepted for all 3 of the test cases. If we submit it, we can kind of get like a sense of how fast it is. So again, this will be like brute force. And as you can see, like the runtime is really slow, faster than 19%. And of course, it's O of n squared. We're iterating through pretty much like, it's not necessarily like every element, but like pretty close to like exactly worst case. So that's why it's pretty slow. And then, yeah, David, do you want to go back to the slideshow and explain the better solution?
Sure, yeah.
Very cool.
So this is the hash map way. So basically, hash map for the two-sum problem, you iterate through the list of numbers only once. For each number, you calculate the difference between the target and the current number, basically the complement. And then check if this difference exists in the hash map. So you only iterate it once, so it's a much faster way than the brute force way, which is n of squared. So if it does, you find a pair that sums of the target. If not, you add the current number and its index to the hash map and continue. So if it doesn't, you'll see in the solution, if it doesn't add up to the target, the key value pair is added to the hash map. And for each other number, it checks whether the hash map contains that key value pair. That's why you only need to run it once. So in this example, it checks if the target is 6 and the first index is 3. So 3 minus 3 is 3. There's no number that contains 3. And 6 minus 2 equals 4. And 4 is in the index 2. So therefore, it will output 1 and 2. Okay. Any questions regarding this? Okay, no questions. So here's the solution of this. So do you guys know the syntax of creating a hash map? So it's like map, then it's a key type, then value type. So in this case, the key type and the value type are both integer. So if you want like a decimal, you would say double, like capital D, then the word double, basically. Yeah, and then always if you need a new to create the object, that's obvious. Then there's a loop, you go through the loop. Same thing as the ordinary loop. It's like nums dot length minus 1 because it's less than, not less than equals. If it's less than equals, you put nums dot length minus 1. And once it goes through this loop, you check the complement. Like check the target. If the target minuses the nums, like number in the index is equal complement. If it contains that complement, and you return the complement. If it doesn't like match the complement with the number in the index, you put it in the hash map. This method nums indices dot put nums square bracket I square bracket comma I. You basically put that number inside the hash map. And if there's no target minus nums equals complement, then you throw like a legal argument exception. Does everybody get this or any questions?
Yeah, looks good to me.
Okay,
Yeah.
yeah.
Can I say something?
Yeah, sure.
So, and how many of you guys even know Java in the first place? Because we understand that they changed Java to Python. So, is there even like a meaning in any of this, like teaching in Java? Because maybe this is only confusing.
Any like
Please,
concepts I need to like explain? I don't know, I usually assume people know arrays, like how to create array, like loop through array.
So,
Like, yeah, speak up if
mhm.
you guys don't know anything. I can do my best to explain.
We're here to learn, right? So just let us know if we can teach you more,
Yeah, for
or if
sure.
we should
Also, we
take a
love to
different
learn
approach.
from you guys too. Like, we don't know everything, so if you guys have any meaningful insight, we would love to learn too. Okay, no questions then. Ashton, can you explain the solution in Python?
Yep. So let's see, where are we? Okay.
Isn't this the same one that? Oh, this is.
You can see the right one now, yeah. Am I controlling it or no? I can't tell, to be honest.
I think only I can control it because I shared it. Yeah.
Oh, my bad.
There's a button saying take control. Can you not do that?
Oh, okay. It's good now? Okay, I think I got it. So this is the solution in Python. So obviously we're going to start with the class and define toSum again. In this one, we're going to define a dictionary data, which is going to be empty. So defining a dictionary is pretty easy in Python, obviously. Pretty light on the syntax compared to Java. So a dictionary in Python is the same as a hash map in Java. It's going to be a set of key value pairs. And basically what we're going to do is we're going to iterate through the array nums. So for x, comma num in enumerate nums in this this loop right here, this for loop, essentially what that's going to be doing is iterating through every item in the array nums. That's going to be represented by num. Because we did enumerate, for every item in nums, it's going to be matched as like with its array index, and that's going to be x. So if we go all the way back, that's right here, to this one, what that's going to look like is for this hash map, the first iteration, x is going to be equal to 0, and num is going to be equal to 3. The second iteration, x is going to be equal to 1, num is going to be equal to 2. The third iteration, x is going to be equal to 2, and num is going to be equal to 4. So then we're going to have this conditional. So if we got the target, say it's 6, like this example, if target minus num is not in data.keys, then we're going to add that to the dictionary. So target minus num in the first iteration, what did we say? 6. So if 6 minus 3, if 3 is not in data.keys, data with the key num, which is equal to 3, is going to be assigned the index, so 0. So what that's telling us is that if we need to find 3, we know the index is 0. Because what do we want to return? We want to return the indices at the two numbers that sum to our target. So that's why we're storing the index as the value and num as the key. So now our dictionary is going to have a key value pair of 3 colon 0. Then we're going to reiterate. So now in the second iteration, x is going to be equal to 1. Num is going to be equal to 2. If target 6 minus num 2, so if 4 is not in data.keys, then data of num is 2, is going to be equal to x is 1. Then we're going to iterate again. So okay, so just to explain that again, data is now going to contain a key value pair that says 2 is the key, colon 1 is the index, or sorry, it's the value that is represented, representing the index 1. So now on the third iteration, we're going to have, what is it? X is going to be equal to 2, and num is going to be equal to 4. So now when we're running this conditional, it's going to be target, which is 6, minus num, which is 4, if 2 not in data.keys. Is that going to run? No, it's not going to run, because in the previous iteration, we ran this with num is equal to 2. So 2 is in data.keys. Therefore, we're going to return x, the current x, which is 2, and data of target minus num, which is equal to 6 minus 4, data of 2. What do we have stored at data key 2? We have the x value corresponding to that value, which is, sorry, the index, which is 1. So it's going to return 2, comma 1. And I don't think you have to put in an array. So the brackets don't need to be there. So do you guys see in the teams where there's at the very top of the screen, kind of in the middle of the bar, there's a little icon that says React. Give me a thumbs up if that makes sense, or give me like a surprised face if you're not understanding that.
I think
Jacob
Jacob
is
has a
raising their hand.
question.
Sorry, what was that?
Looks like Jacob
Think-
has a question.
Yeah.
Okay, let me take a look. Oh, misclick. Okay. Oops. All right. Everybody's good?
Yep.
Keep raising my hand by accident. Okay, I just want to draw it out just so it makes sense. So here is, oh my God. Okay. Okay, here's our dictionary. That one looks better. So for we have like, oh my God, this is hard to write. Okay, we have key value pairs. First iteration, what are we going to have? We're going to have key is equal to num is equal to 3, and then we're going to have its index. Second iteration, we're going to have key is equal to num, value is equal to index. We're going to have 2, colon 1. So then when we get to the third iteration, when we have target, which is 6, minus num, which is 4, if 2 is not in data.keys, we're adding it to the dictionary. But 2 is in data.keys. So what do? We return x, which is 2, and data of 6 minus 4, 2. So data of 2, what corresponds to data of 2? 1. So this is what we return. Okay. Do you guys want to see that in LeetCode just for a comparison of the speed that it runs in, or it runs much faster essentially?
I think Anne Reed said she wants it in Java, like the same explanation.
Okay. I'll pass it over to you guys then.
Okay, sure.
You or Vansh can take that.
Okay. So basically, you guys know like class obvious, like the header method toSum, like it returns an int because, you know, it returns an int array because there's a square bracket and the variables are inside the round brackets. Okay, I'm mostly gonna talk about hash maps because I think that's the new stuff like that our people are trying to learn. So like I said before, hash maps, you only iterate through the arrays once. You don't check like for an inner loop. You guys know the syntax of a hash map, right? So basically integer is the key value and the other integer is also the value type. So I know that if you want a decimal, you put double and double, and then you do a loop like nums.length loop, and it starts at 0 because that's the normal array. You check for every iteration in the outer loop, and the smart thing is you check the complement, which you can do with a hash map. So complement is basically target minus num square bracket I. So there's a method in hash map called contains key complement. So if the hash map contains a key that's a complement, then it will get the complement and will return that complement to the output. And if like this one nums indices dot put square bracket square braces nums I comma I, like that one, like if it doesn't contain a complement, it puts that right. Okay, it puts that number inside the hash map for it to look up in the future. And if none of the can you explain can you explain hash map
Right.
in brief at first? I don't have any prior experience.
I'll
Hash
take
map?
it. I'll take it.
Okay, yeah,
I'll take
sure.
it. Okay. So basically, what we mean by hash map is a key value pair. What's a map? It's basically you're plotting keys with values. So the first question arises is why are we even using hash map in this question? Why can't we just create another array to look up and save the values in it? The answer is because hash maps. If you wait, can I take the control? All right. Right. So with hash maps, the point is if you look at this, can you see my arrow as well on the screen?
Yeah.
David? All
Yeah.
right. So this only method is the key here, contains key. So what happens is when you look for any element in the hash map, it's not gonna iterate through the whole hash map. It'll just return you the answer. For example, if you have an array of 100 elements and you're looking for one element in it, the solution would be you have to go through all the element one by one, and when you reach the solution, you just return that element. But the thing with hash map is if you just run this method, hash map dot contains key, it's gonna return the key and the value of that whatever you're looking for without going through the whole hash map. So it's way faster than using an array. Now, what exactly an hash map is? As the name suggests, it's basically an hashing algorithm. And after running the hashing algorithm, it's gonna map the elements. So, for example, let's say in this question, we are basically storing keys with values. So if we go to here, so what we're trying to do is the array is 3, 2, 4, and on the 0th index we have 3 here. We want to store 3 as the key and 0 as its value. So when you put 3 as the key, it's gonna hash it using an algorithm which is in the back end of the hash map, and it's gonna give us a key, and on that key it's gonna store this value. Now same thing's gonna happen with 2. 2 again, 2 is gonna go through an hashing algorithm and it's gonna be saved as a key, and for that key there would be an adjacent value which is gonna be 1, and same thing with 4. So the basic, as I think Ashton suggested, and can you give other examples of key? Key can be anything. So if I give you a bigger example, let me open my LeetCode maybe.
It can be strings too, like red, then 3. Yeah.
Yeah, so wait. Here in the syntax, we can see the way we define it as map, and then inside it, we basically define key and value data types. So in this case, they're both integers, but they can be any data type, and we use a parent class. So we won't use int, we're going to use an integer class because it's the way it's defined. And yeah, it can be a string, it can be a double, it can be a float, it can be any data type, to be honest, as long as you're going to go through the hashing algorithm. So, do you have any specific question with hash map, maybe, if you still don't get it? Basically, creating hash map, we are trying to create a lookup table for us to review the whole array later. In this example, for say, we are going through the array once, and then after every comparison, we are looking into the hash map again to see if that element we already went through. And if yes, then we just return it. And if no, we just carry over. So you get it? You can react using, can you put? Six element key value as 6 element. What do you mean by that? Okay, David, do you get the question? You mean this 6, the target? Okay, cool. I can try, yeah. Okay, let's say, can I make it bigger? Okay, let's say let's say the array is 1, 3, 5, 4. And the target we're looking for is, since you don't want 6, let's say it's 9. Cool. Now let's create a hash map. So in the first iteration, we will go to 1. So 1 will be stored as a key. And what's the value for 1? It'll be 0, the index. So this is the first input in hash map as a key value pair. Now we'll go to 3 and then we'll check if 9 minus 3, that is 6, it exists in the hash map. Since 6 is not in the hash map as a key, we'll again input 3 on index 1. Same thing with here. We'll go to 5. We'll say 9 minus 5, that is 4. Is 4 already in the hash map? No. So we'll input 5 in the hash map. Now we'll go to 4, the final element in the array. And then we'll see if 9 minus 4, that is 5, is already in the hash map. It is in the hash map, which is 5, which is here. So in this case, we'll just return the value adjacent to 5, that is 2. So we'll just return 2, comma, the index we are currently on, which is 0, 1, 2, 3. So 3. So this will be the output of the solution. Is that what you meant by a different example? Okay, perfect. Okay, David, you can take over now.
Okay, sure. So the next question is best time to buy and sell stock. Let me go to that question on my web browser. So it's basically a question where it asks you to find the best time to buy stock. It's like a difference question. It's like a mathematical question. So we're giving an array of prices where prices I is the price of a given stock to ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. So your goal is to maximize profit you can achieve from this transaction. Hold on. What do you mean by sliding window problem? Can you explain?
I think it's just a different algorithm.
Oh, I'd love to learn about the sliding window problem if you could explain that. Okay. So there are like other patterns like two pointers, hash maps, and graph. So this problem is essentially asking you to find the maximum difference between two numbers in an array where the larger number sell price comes after the smaller number buy price. So it's a mathematical problem. So basically it's you can use the normal arrays for this problem. So here we put min price equals to integer equal to dot max underscore value. Why we do that is we want to put an upper boundary, so any min price will replace the maximum value. Integer maximum value is basically the maximum number for an integer. So we set max profit to 0 because 0 can also be replaced by any max profit in this solution. And we go through the loop. It's the normal loop. You start at index 1, and then you check if the price I is smaller than min price. Okay, hold on. What if more than one solution exists if we have the array as, will it provide more than one result?
Oh, so in that question, it's given that one and only one solution exists. That's a boundation. It's already in there. So there's only one solution in our input. So the input you provided is an incorrect input for that problem. Perfect. Yeah, I think we should explain the question properly as well.
Or do you want me to share
just,
my window screen too, like my screen?
Yeah, I
Okay,
guess if you
hold on.
just explain the question first, it'd be better.
Yeah, so this is the best time to buy stock. So it's a difference question. You're just trying to find the maximum difference between two numbers in an array, where the larger number should be the sell price, because obviously, like when you're trying to make a profit, your sell price should be the most and your buy price should be at the minimum. Okay. Oh, what happened? Share my PowerPoint. So do you guys understand this solution? Do I need to explain any particular code? Or is it all good? I think this one is more of the easier side of problems because it's just normal arrays. Sorry, I got kind of sick, like I have a kind of cough, so I'm not at my voice is not at my usual. Yeah, so basically, you're just replacing the min price until like your price is greater than the max price. Like it goes through the entire loop. It finds the maximum profit for it. There's a for loop, then it checks the price, it replaces the min price, and then it checks for the max profit. So the max profit is like prices minus min price. Then you return the max profit. Is there any code that I need to explain further for you guys to understand? Or is this all good?
David, do you mind if I explain the Python one real quick then?
Yeah, sure. I just want to make sure people understand if the current price I is less than min price, then they update the min price. Then if the difference between the current price I and min price is greater than current max profit, then update max profit. That's the basic logic of the Java code and the Python code. Yeah. So go ahead. Yeah.
All right. So it's pretty simple. We're going to initialize profit as 0, and then at the very end, we're going to be returning profit. So if we have a case like this one right here, where the price is always decreasing from one step to the other. There's never a time where you can actually profit. So by initializing profit to 0 and then returning profit, you can always return 0. We're going to initialize the min price. It's the first element in the array. And then we're just going to loop through the array once. So for x in range length of prices, we're going to have a little conditional here. So if prices at index x is less than the min price, we're going to update the min price, like David said, and it's going to be set to prices of x, index x. Otherwise, if prices at x minus min price, so if this one is executing, because this is else if, that means that this is untrue. So prices at x is not less than min price. So it's either equal to min price or higher. So the profit will either be like 0 if prices x is equal to min price, or it'll be higher. So then, basically, if prices at index x minus the minimum price is greater than the current profit, which is initialized as 0, the profit will be updated to prices at index x minus min price. You can iterate through the entire array once and then return the profit. Run it, see it's accepted. It's pretty fast. And yeah, this is a pretty fast one. Just a single pass O of n. You can see the runtime is pretty fast. And yeah, that's about it. I'll pass it back over to David now.
Okay, sure. So we'll go to the next and the final question, which is duplicate. Okay. So this is the duplicate question. Let me show my screen again. Screen, okay. It's time to play stop. It's duplicate. So I think for this problem, the title is pretty self-explanatory. It basically checks if the value appears twice in an array, at least twice. So it can appear 3 times, that will return true as well. Twice will return true. More than twice will return true. If it doesn't repeat itself, then it's false, like for this example. Okay, so the first method, we're going to use the brute force method again. And for the future methods, we're going to use hash set, which basically is for unique values. So that's a kind of different from hash maps. Okay, then if it will find the first combination of works in the solution to return. The second 4 in the list will not be touched as 4 at index 0 and oh, this is Alexander's comment.
Yeah, this is me trying to answer the question.
Okay, I thought there was another question. Okay, so contains duplicate. So basically it's same like logic. You go through the array by looping through it. You check if 1 is equal to 2, no. 1 equal to 3, no. 1 equal to 1, yeah. So it just iterates through from a outer loop to an inner loop. So here's the solution. Yeah, so if you guys have any questions, I can answer it. But its basic idea, you start at index 0, then 1 plus I plus 1, because you don't want to start at the same index. You want to check for the number to the right of the index. So if the number to the right of the index equals to the number, then it returns true. If it doesn't, it returns false. So if you guys have questions on that, I can explain that. But it's basically the same logic in all 3 questions in the brute force. Okay. So this is the brute force method. And now let's go to the array sort. So this is another smart method. Is basically you take the array elements and you sort it by ascending order. So like, for example, in this case, 1 is beside 1, then it's 2, 3. Do you guys have any questions on that? Okay. All right. Obviously, array sort is more efficient. I'll go to the code because it uses one loop. So, like when you use two loops,
Again, wait. So it's not as efficient as looking right now because we're using the sort method in here, and sort method itself is n of log n, so it's more than one loop. So it looks more efficient, but it's kind of same like the previous one.
Okay.
Yeah, I mean, if
So the
we
previous one is log of O of n squared, right?
yeah, it's O of n squared, but if we sort it ourselves using any normal sorting method, then it's going to be the same complexity. But if you're going to use the Java's method, which is quicksort, it's going to be O of log n log n, sorry. And then if you add log n to it, it's going to be n log n again. So it's a bit faster, but again, if we use set, it's going to be better.
Okay. Gotcha.
It depends what sorting algorithm you're using. It can be recursive. It doesn't matter, to be honest, because recursive is again a sort of algorithm, and the one we're using in here, it's called quicksort. It's defined inside Java, and it's n log n. So it's faster than using two loops or using something like selection sort or insertion sort or or bubble sort. But it's still not as efficient as the last algorithm we are going to show you guys, which is using hash sets. So yeah. Same thing again, merge sort is n log n. There is no sorting algorithm faster than n log n, so perfect. Yeah, you can continue, David. Go for it.
Okay, so array sort. So you go through this loop and you check if the number and the number to the right of it is equal. It returns true. So that's the logic of it. I think it's much neater, this code, than the brute force one. Okay, so Python. Vansh, do you wanna take over?
Yeah, I can touch it. Okay. Okay, so in this Python code, it's pretty much the same code. We are first sorting the array in ascending order. That's the default. And then we're gonna loop through the array using I'm not that good with Python, but for in range. So I guess it's gonna iterate the array from I equals 0 to I equals the length of the array minus 1, which is the last element in the array. And then we are gonna check if any two adjacent elements, if they're same, because since we sorted, if one element is repeated two times, they're gonna be adjacent to each other. So if we find any adjacent element, then we return true. And if we don't find anything after parsing the whole array, we can return false. Yeah, same thing like Java, pretty much. Different syntax. Okay, so next is using hash set. Do you want to take it or you want me to
Yeah,
take
sure.
it?
I just want to put an interesting note. So I know Java for collections like array list, there's actually like a collections method. You can put the order of the arrays in a descending order. So it's basically collections dot sort. For example, in this case is nums dot comma collections dot reverse order. Square round brackets.
Right. Yeah.
Yeah.
By default, it's ascending. You can make it descending though.
Cool.
Okay. Okay. I think Iskandar put in the time complexities of both the solutions we gave you guys. The first one, brute force, was O of n squared because we are using two loops in it, and they are both nested loops. And the second one, using sorting, is O of n log n, which is basically because we're using the sorting method, which is n log n. And the third one, which is using hash set, is going to be O of n, which is going to be the fastest solution. And why though? What's the reason? Why is the hashing so fast? Let's explain it. So hash set is kind of like hash map without a value. It just stores key, and using the same logic that if you go in and ask for any key, it's going to return the solution in a constant time, which is O of 1. So if let's say this is a hash set, it has 3 keys in it, and you basically query this hash set asking, do you have key named 2? So it won't parse through the whole hash set. It'll just return you the answer in a go, which is constant time complexity. It doesn't matter if this hash set has 1,000 keys or 10,000 keys. It's going to return the solution in a constant time. That's why we use hash sets to look up for any value in it. Or in other words, we can say the searching complexity or the time complexity of searching in a hash set or a hash map is constant time, which is O of 1. That's why we use them to create dictionaries and all. And if we look at the solution, no, after the third one. Yeah, perfect. As you wrote. Okay, now as we look in the solution, we created a hash set. It's pretty much same as we created a hash map. We just replaced the map with set, and in this one, we don't have to give the data type of value because we are just storing the key in it, and that's why it's called the set. And same thing, we're using the new keyword to create a new instance of hash set class, and then same thing, we're gonna loop through the array once and only once, and then in the first if statement, we are checking if the hash set already contains the num. If it does, then we return true. If it doesn't, we return the wait, are we? Yeah. If it doesn't, then we return the num. Let me take control and give an example of it. Let's say the array we have is 1, 3, 5, 8, and 5. That's a successful. And let's say we have a hash set here. It's only going to contain keys in this case, so we don't have any values. So we'll go to the first loop. It says for nums, and it's a for each loop. So we are not going by the index. We're directly going by the values. So the first value of num in nums is 1. Now we're going to check if the hash set, which is empty right now, if it contains the value num, which is value 1. It doesn't because it's empty right now. So we'll just add the value num to it. So we'll just add 1 to it. And we'll go to the loop again, and we'll be like, the second value for num is going to be 3. We're going to check if 3 is in there. It's not in there. So we're going to again add 3 in here. Again, for this, we're going to do the same thing with 5. We'll go to the hash set. We'll ask if you have 5. It's going to say no, I don't have 5 right now. So we'll just add 5 again. Same thing with 8. It doesn't have 8. So 8. And then 5 reappears. So in this if statement, we're going to ask the hash set if you have a key named 5. And it's going to be like, yeah, I have a key 5 already with me. And in this case, we'll just return true. So since 5 appeared 2 times and it returned 5 and it returned true when we again reached 5 in the array. So this solution is O of n because we're just using one loop. And this contains method here. It is constant time. As I just suggested that when you look into, when you search an hash map or hash set, it's constant time complexity, which is O of 1. So this line here is constant. So we're just taking consideration of this loop, which is O of n. So the whole complexity of the problem is going to be O of n. Right, yeah. And one more thing is, so returns a Boolean value or not. It returns the Boolean value. Wait. I have to look into the question. I didn't create the solution, so. David, what are we supposed to return in this case?
I believe it's a Boolean value.
Why does it say integer here? Should be bool, right?
Yeah, Boolean value.
Oh, right. I think he used the wrong method in here. This is a different question. It's supposed to be bool.
Oh yeah.
Yeah.
My bad, wrong question.
No worries. I mean, the solution is still the same. Just
Yeah.
replace int with bool here and return. Yeah, no worries.
And yeah, I think I need to change that. Okay, yeah. Also hash set doesn't allow duplicate values, so that's something to note.
Yeah, because it's key, right? And it's
Yeah.
basically you're passing a key in here and it's gonna hash it to some other value. And if you again pass the same key, then the hashing algorithm is gonna do the same thing again. It'll just overwrite the previous key. So since it already has a key, it's not gonna add it again. That's why we use sets and hash map. Again with hash map as well. If you have a key and you put in a value in there and you use the put method again for the same key, it's going to overwrite the previous value instead of saving it again. So yeah, that's it's always used to store unique elements in it. Yeah, perfect. Yeah, you got it. If you have an array which has many duplicate elements and you need to create like something which has no duplicate elements in it, you can use set. You can just create the array to set and it's gonna remove all the duplicate values. Okay, let's look into the Python solution. It's pretty much the same. You with sort of an easier syntax. You create a variable called data with this keyword called set. It's gonna create a hash set for you, and then you loop through the array, and then same thing. You look for this number. So x is in this case we are not using for each loop, so we are going by index. So if the first index, so the element at first index is already in the hash set, if yes, then return true. If not, then just add it to the hash set and do the same thing like we did in the previous one, the same example. And when the duplicate value comes, it's going to return the true statement and you're good to go. Cool. If you guys have any questions. It is just n log n, it's not n times n log n. Who said that? Okay, let me go back. Oh, did you write it in the chat? No worries. It's basically n plus n log n, which comes up to just n log n. This one, yeah. Yeah, so we give you 3 different solutions with different time complexities. And the last one is the most efficient because it's O of n. Yeah. I think that's pretty much it. If you guys have any questions or any sort of concept you want us to go again to.
It looks like nobody has any questions.
Yeah, looks like it. All right.
Um,
Okay, David, you can take over. I don't know what you plan for it. Can we do a practice question on hash map? Okay, yeah, let me look for some. Give me one sec.
By the way, you mentioned that in the hash set, it's good for eliminate duplicates because it doesn't allow those, right? It just
Right.
doesn't do anything if it's the same,
Yeah.
right? And the same
Right.
works for hash map, if I'm not mistaken.
In hash map,
Whenever
if you try
to put,
yeah, it's gonna override the previous value. So let's say for key 1, you store the value 2 in there, and then you do the same thing again. You store the value 3 for the same key. It's gonna override the 2 to 3. So yeah, it's not gonna save like 2 different key value pairs. It'll just override the previous one. Let me see. Valid anagram. Okay, let me see. Okay, let me find an easy one. We're gonna cover blind 75 in next meetings anyway, so let's find something else for now. Yo, David, do you have some hash map questions? I don't trust LeetCode. Oh, yeah. LeetCode labeling. .
Sure, yeah, I think you can just search hash map in the search bar or the problem list in LeetCode. So you want easy or medium, or I think easy, right? So there's a mid-cost climbing stairs question.
Let me see. You found something? Wait, I think I found a question, maybe. Let's look into this one. I'm not sure if it's the easiest one to explain right now, but let's try. Okay, can you see this one? So the question is called number of good pairs, and it's gonna give us an array called nums, and we have to return the number of good pairs. Now, what is a good pair? A good pair is a pair I comma j if the value of at both the indices is same and I is less than j. So basically, this and this is gonna be a good pair. And in this case, we have 4 good pairs. So this comma this, again this comma this, and then 3 comma 3. So, and let me hide the solution first. If you guys wanna take a go at it, like I don't want you to code right now, but just give me the logic of how you wanna go through with this one. Wait, if anyone is trying, can you give a thumbs up? So I know. Okay, you're trying. Perfect, man.
So, how are you guys doing? Any progress? Any questions?
Just give them like 2 more minutes and then I'll just go over it.
Mm-hmm.
Okay, guys, anything? Guys found some kind of logic to it, like how to progress? You start.
Hey, I think that like
Mhm.
as per what I understood today, first we can make a hash map and we can assign a good pair number. We can assign a good pair number 0 at first.
Mhm.
Then uh, we can just we have to what can I say, iterate all the arrays to update the hash map numbers. So we can use a for loop for that and then calculate a good pair for each number for from that for loop.
What are you storing in the hash map?
Integers.
Yeah, I mean, what is the key? What's the value?
Uh, like uh, I didn't got that. Like
Sorry.
I didn't got that. Like what like storing in hash map.
Oh, okay. So how are you gonna calculate the good pairs based on it?
Yeah. So Isn't it supposed to be like a good pair? Like first I have to give initial value of good pair, like as a resulting value of good pair initially as 0, and then I have to count the number.
I'm not getting it. What do you mean by giving 0 as a value? So in this case, we have 4 good pairs. We just need to return the number 4. So you're saying the number of good pairs is 0, initialized it with 0, right?
Yeah.
Yeah, and then
And
you said you are going to create a hash map.
yeah, and then using all the number we can take all the numbers from the array, and
Yeah.
then we can go one by one to each and every number in the hash map.
Yeah, so you're going through all the numbers in this array. Let's
Yeah.
say, so you're on 1. In this case, what are you going to store in the hash map? What's the key? What's the value? You're on 1 right now.
Should it be one cause wait, now I'm getting confused. Just a second.
It's okay. It's okay. It's okay. Take your time.
Yeah.
Anyone else? You guys get something?
It's kind of similar to the duplicate problem, but with hash map.
It's kind
you
of,
use,
yeah. Not
Because you use
exactly.
the
but
same method, contains.
I use the same method.
I mean, you guys probably use the same method, contains, right?
Yeah. If you use hash map, then yeah, you're gonna use contains anyways.
Yeah, that's like the equal assignment for the hash maps.
You can look for a different solution too, not just hash maps. You can use 2 arrays or something. Can be anything. It's just the first meeting. You guys don't have to be the most. You guys don't have to give the most efficient code. If the logic works, then it works.
Yeah, I think that's the most important thing.
Yeah. No, the first objective should be to create a logic, and then you can minimize the time complexity later. But yeah, initially you should get to the solution first. Do you need more time, or we just go over it now? Just give me a thumbs up if you need more time. Jacob needs more time. Okay, cool.
Did I understand you correctly, Vansh?
Yeah, perfect. Yeah, that was my question. Like, what are you doing with the hash map exactly? You're looping through the array, but what are you storing in it?
So Anrit is giving some ideas. What do you think, Vansh?
Let me see. Key 0 when value is 0. Target equals to 1. What do you mean? I don't get it. key is 0 when value is 0, because target equals to 1 at index 0. So you're saying the key is 0 and the value is 1? That's what you mean? Can you just give me yeah, okay. So when I equals 0, at index 0 the value is 0, right? At index 0 the value is 1 in this example. Since we're looking if it contains the same number, means our target is that number. Yeah, so the good pair is not just 1, 1. It can be anything that is repeated 2 times. So it can be 3, 3 as well. So we need to count all the options in here. And the answer we can say we can see 2, 5 is an answer, and which is 0, 1, 2, which is 3, 3. So anything that is repeated 2 times can be a good pair. So I don't think looking for a target is a good idea, because it can be anything. Okay, guys, just 2 more minutes and then we'll just go over it. So are you using a nested for loop in this case with I and j? Say yes or no. I mean, it's a good idea what you're trying to say. No, okay. What exactly are you trying? What is I and what is j in this case then?
So I think she's confusing what I and j, right? They represent like different variables in each loop.
Right.
In that case, because you need to compare each value with all the other numbers, right?
Right. Then you.
So
if you're gonna, yeah, go for it. Go for it.
So when you have like this approach, right? You want to compare index 0, right? Compare with all other indexes. Okay, so it goes 0 and 1, 0 and 2, 0 and 3, and etc. Okay, but you need to do it with every number. It's pointers.
Yeah, even if it's pointers, yeah, even then you have to compare them with all the numbers. You're just saying if You're just saying if they're not equal, you're just incrementing I and j both. But there's a chance when you just increment j and I and j matches, right? You're just missing a lot of options in here. So for example, you initialize I with 0 and j with 1, let's say. And if they're not equal, you're saying I is gonna be 1 and j is gonna be 2. J is gonna be 2, right? Right. Yeah, you're in this case you'll just miss this second possibility, which is I is 0, j is 2. Okay. I mean that's a good approach, but you just need to use two loops for it. Cool, guys. So I think I should go over it for it now. Or do you guys have any more solutions? Jacob was working on it, I guess. Have anything to share? I gave up. Okay, no worries, man. Okay, okay. That's purely one of the solution. It's not the only solution in there. So that's what I made. So I created an hash map, again, integer, comma, integer. So the key and value are both integers. And I basically went through the whole array. And what I'm trying to store here is how many times one is repeating. So in this case, one is repeating 3 times. So the idea is, let me write here. That's my idea. So 1 should be mapped to 3. Second case, 2 should be mapped to 2 is just 1 times. So 2 should be mapped to 1. 3 should be mapped to 2. I'm not sure what this is. Yeah, so that's my idea. That's how the hash map should look after going through this loop. And the logic for it is simple. It is that. So you basically go through every element one by one and you check if a map has that element or has that key. So in the first case, we'll check if the map has 1 in it. Since the map is empty, we'll just put, so this case is gonna be false. So we'll just go to the else statement and we'll map 1 with 1 because yeah, that's the first time of occurrence of 1. And then we go to 2, same thing. Since 2 is not already in the hash map, we're gonna put 2 comma 1 in the hash map. So that means 2 is just 2 has occurrence of 1 in the hash map for now. Then we have 3, same thing, 3 comma 1. And then now we have 1 again. So what we're trying to do is since map.contains key 1 is gonna give us true because the map already has 1 in it. So what I'm trying to do here is I'm trying to map 1 again, but incremented the previous value of 1. So this map gonna get 1 is gonna give me a 1 because that's what I mapped it with before. And I'm just incrementing it with 1. So 1 plus 1, 2. So that means now 1 is occurring 2 times in the hash map. And again, for the next increment, we're gonna map it with 3. So at the end of the day, we're gonna get something like this for the hash map, right? Now, we gotta reach this solution, how many good pairs we have. So let's just say the array looks like this. How many good pairs do you guys think we have in this case? Just give me a number. 1 comma 1 comma 1. How many good pairs do we have in this? Three.
Yeah, this is saying 3.
Got the same. Again. So look at this line. So it says number. So both the indices have the same must have the same value, and I should be less than j. So if you look into this condition, how is it 3? Okay, let's okay, let's try to solve it.
0, 1, 0, 2, and then
0, 1,
1,
0,
2.
2, and then 1, 2.
0, 1,
0, 2,
0,
0,
2,
2,
and 1, 2.
and 1, 2.
perfect, perfect, right? Now, so since 1 is repeated here 3 times, and the answer you got is 3. Now let's do the same thing. Let's do some math here and let's try it with 4 ones. How many solutions are you gonna get in this case?
6.
6. Okay, let's see. 0, 1,
0, 1, 0, 2,
0, 2,
and 0, 3.
0, 3,
1, 2, 1, 3.
1, 2, 1, 3, and then 2, 3, I guess. Right? These are 6. Okay, do you guys see any pattern in here?
It doubled.
It doubles
So-
up.
Okay, let's do it with 5. Just give me the number. How many do you get for 5? It's not gonna double up this time though. Or you can just say 5 is a lot, right? So you just do it with two ones. It's just one pair, right? So from 1 we reach 3, so it's not doubling up. So that's not the solution. So it can be solved as something like NC2, like n combinations of 2. If you guys did you guys do permutation and combination in math before?
Yeah.
So if you solve any of the permutation for this, for example 4C2, what is 4C2? It's 6. What is 3C2? Is 3. 5C2 is gonna be 5 times 4 by 2 is gonna be 10. So it's gonna give us 10 solutions, right?
Yeah.
So, and this is basically how NC2 solves up to. So I times I minus 1 by 2. So you can basically, I can write the, so it's n factorial divided by n minus 2 factorial. Sorry. Times 2 factorial, or just 2, same thing. So if you just solve this thing, it's gonna give you this. Because let's say, can you give me 1 sec? Right, so sorry. So n factorial can be written as n times n minus 1 times n minus 2 factorial, and if we divide it with this, we can cancel n minus 2 factorial from it, so we just get n times n minus 2 by 2, and that's what I use here. Sorry, n times n minus 1 by 2. So for every repetition, let's say 1 is repeated 3 times, it's gonna give us 3 good pairs. So we're gonna increment 3 to this answer. We initialize answer with 0. We're gonna increment 3 to it, and then we go to 2, which is just repeated once. So since if 2 is just repeated once, so we cannot get any good pair with it. So I just said if I equals to 1, then just continue. You don't even look into it. And again, 3 is repeated 2 times. So we go through the formula again, 2C1, and you increment it to the answer and you return it. You guys got it? If you have any questions, let me know. Perfect. Sounds good. Yeah, can you guys give me a thumbs up if everyone got it? And if not, you can ask questions. Cool. 2, 3. Okay. Perfect. And are you guys good with hash maps now? Like, you know what's going on there? Hash maps, hash sets. All right. Okay. Okay, I'll just stop sharing. Yeah, sure, we'll do it. Sounds good. Okay, David, you can do the closing. I don't know how to do it.
Yeah, sure. So
Okay.
I'm just gonna talk about what this club is about. I made this club to learn also. So I think we're like trying to make a collaborative learning environment to learn data structures and algorithms. So I think what we're doing is a good start. So yeah, let's have fun and let's see you guys next week or the week after exams. If I'm not able to come next week because of exams. All right. Thanks, guys. See ya.
Yeah, have a great weekend, guys.
You gotta stop the recording, man. Sorry. Stop.